Welcome to the Data Driven Manufacturing Podcast, where we explore how data is transforming the manufacturing world. My name is Rowan Easter Robinson, and I'm an engineer at Track My Machines. I'll be talking in every episode to engineers, business owners, and professors who are leading the way in data-driven manufacturing. Let's get started. So today I'm here with Gareth Evans, and we're sat in a building in Sheffield. One of our both of our hometowns, spiritual hometowns, I guess. Gareth, could you give us a little bit of a background to who you are, please?
Okay. Well, I've lived in Sheffield since 1994, but originally I'm from South Wales, so I'm a Welshman. But I've been away from Wales for many, many years. I did my PhD in the medical school in Cardiff. It was an area really of cancer biology at that stage, and I moved up in 1984 to the Christie Hospital in Manchester, where I did a postdoc and stayed there for nearly 10 years. And eventually, as you do, you look for something a little bit more permanent, and I applied for a lectureship at the University of Sheffield Medical School. So we all came over here in 1994. That was my wife Alison, and we had one child then, Reese, who was a few years old. And so we moved into the outskirts of Sheffield, Dore and Totley, where we've been since then. It's a lovely point. Absolutely love Sheffield from the beginning because people are so friendly. It's just like South Wales. And where we're on that perfect point where we can get into the city very quickly within about 20 minutes, but literally you can walk from the house.
I don't shout about it too much, Gareth. You know, we might get flooded with people.
I'm a convert to Sheffield, it really is. Completely. And, you know, as far as we're concerned, it's our place for life, really, because we're here. My son now, he's married, has children, so he lives around the corner. My daughter came back to live with us for a year or two after university, but she's now with her boyfriend down in Epsom, living with his parents, and they've both got jobs. So people are settled, we're settled, and you know, it's been a great time, really. We've really enjoyed every minute of it.
Yeah, totally. And from with this kind of medical background, people might be wondering why you want a manufacturing podcast. So we've got coming up, basically, we're going to be talking about health and safety applications in machine shops, and these are things that we're going to be talking a little bit about standard stuff like COSH, Health and Safety Work Act, but actually there's a hell of a lot of things that aren't really covered by legislation, are actually affecting people's health right now in machine shops, and stuff that we need to know about.
Yeah, it does seem a strange conversational point, really, if someone that's got such a sort of strong background in health, particularly lung disease and immunology. What are you doing in manufacturing industry? And it's probably worthwhile saying something about myself again first to explain that. When I started off, I've always had a very broad interest in sciences. So I was always good at biological sciences and perhaps not so good at the mathematical physics side of things. I still enjoyed many of the topics. So when I was doing my biology in school, I equally liked geography, and I liked geological mapping studies. I like meteorology, and I couldn't stop myself from really finding out more about those things, but sort of thinking about how you all fitted them together, which really the education system then didn't really allow. You know, you're going to have to specialise in biology, you're going to do biology, you're not going to do anything else. And that carried on in university. So I used to spend a lot of my time tinkering around in chemistry department, because I did that in the first year as well, trying to work out how we could sort of bring some sort of chemical knowledge to something else I was particularly interested then, which is quite unrelated to what I'm doing now. It was actually to do with the actual insect exoskeleton. And the exoskeleton is really quite a complicated structure that allows insects both to breathe, but also to retain moisture. And they can do so in incredibly dry environments like the desert. And I wanted to know a lot more about some of the oils and lipids that are present in that structure. And so I used to go and talk to my chemist colleagues. And that's where I started off. When I started my PhD at the Tanner's Institute in the University Hospital in Cardiff, I used to go around the building, because it was a fairly small institute, talking to other people who were doing a lot of biochemistry, some of the early days of molecular biology, just trying to find out more. So I've always had that small c Catholic interest in other subjects, never been able to stop myself finding out, reading books about that. And I think that's translated into my approach. So even when I came to University of Sheffield here, and I was in the children's hospitals, and we were looking at respiratory diseases in children, and particularly certain viruses that affect children, things like respiratory syncytial virus, which affects young babies and can be quite life-threatening if they catch a severe episode. I also wanted to know from my colleagues in the main part of the medical school, what were they doing on relevant methods that would allow us to analyse infection, or to look at transmission. What were other immunologists doing to try and understand why the defences in young babies seem to be so poor at dealing with this virus infection? And I think I carried that later on. We'll talk a little bit later as I moved from the university to health and safety executive about the sort of broad interests I developed there. But one of the things that particularly caught my attention from a very early stage was how can we actually apply our knowledge in real world circumstances? And I got a great deal out of the work that we did at the children's hospitals because we worked with the Sheffield Children's Medical Charity there, and they were very demanding, rightly, that they didn't raise large amounts of money, but when they gave you some money, what we're going to see in terms of real world outcomes from this research that would help either help understand when children had the infection, help the doctors who are treating them understand better approaches to treating them, those people developing vaccines, how could we improve that knowledge. And so that's always been, I think, something that's really strongly influenced me. How do we use the resources we've got in terms of knowledge or financial resources to actually, in a sense, develop the best outcome for people? And I'll say one last thing really about my time at the Children's Hospital in Sheffield. When I went there, I arrived and I had an empty desk and an empty office, a little bit like this here. And so I had to think, how do we actually start this whole process of developing the research? And I did that by just talking to lots of other people, talking to lots of charities, who then started to fund us anything from a few £100s to tens of thousands of pounds. And within about 3-4 years, we probably had one of the best equipped facilities in the University of Sheffield at that time in the medical school. We had several floors dedicated to different areas. We used to use a lot of tissue culture, which is where you can actually grow cells outside the body to study what's going on when you apply treatments or you're looking at how viruses infect them. And so we'd literally set that up, but we'd done it, I think, by engaging with lots of people and getting lots of people involved. And so that's been another thing that I've always wanted to do in my career, is whatever you do in terms of research, whatever types of people you're working with, find ways that you can engage with them. I'll give you one or two other examples when we get to talk about the time I had at HSE.
Yeah, exactly. So, and you heard that right, this man was also a health and safety executive. There's not many people, I guess, you get to meet on a daily basis that have worked at HSE. It's kind of, when I was an apprentice, it's kind of this acronym you don't really understand. And when they say, when HSE come in, you best be wearing your glasses. I had no idea what it meant when I was an apprentice.
In a sense, it's unfortunate that the main way people get to know about it in the manufacturing world is often that sort of slight sense of fear, apprehension, are we going to be closed down, are we going to be fined, and so on. But it's just the wrong way to look at it. And I'll explain briefly how I got to get into HSE. I'd been in the university for about 10 years, but I had reached a stage where I felt I was seeing an awful lot of effort being put into raising funding and money, and a lot of competition and people being judged on how much money they brought to the university. But when you looked even at those who were very successful at bringing in often millions of pounds, you often found they were doing some beautiful research. They were publishing in top-notch journals, but actually there was very little translational work going on. There was very little discussion when you got together in research groups in terms of what have we actually achieved in terms of progress of the research. If I can get my funding, if I can do my research, if I can establish my academic career, I'm made. And I just lost interest in that.
The incentive is to get citations, is not to get applications.
Exactly. It became a very sort of personal ambition approach to how I can advance my career, not in terms of really asking myself, what have we achieved for people? And it was just talking to colleagues who already were working then at the Health and Safety Executive's Scientific Laboratory, which was based at Broad Lane in Sheffield, within the university campus. And two of my friends from the medical school had gone to work there, and so I was talking to them. And they said, you know, we've got a health effects team that's been set up at the laboratory, investigating lots of things like respiratory disease. And the problem we're having really is we need to find people who are interested in doing translational research, taking their experience and knowledge, but actually working out in this messy, complicated world of the working world, how can we actually understand what's causing respiratory disease, but how can we either prevent it? And that often doesn't mean the same thing as you might be doing in the medical. That doesn't mean going off and then spending years developing a sophisticated, clever drug, millions or hundreds of millions of pounds. It might actually mean understanding why people do things the way they're doing and using that behavioural approach to stop them inhaling that hazard and developing lung disease.
Yeah.
Whereas in the past, you've probably seen this all in terms of what's the mechanisms, can we understand how the mechanisms work at the genetic level, how do we then intervene in terms, and so you're talking about 10, 15 years of research, certainly was in the past.
It's taken 50 years of obesity to get Ozempic.
Exactly.
Instead, you just tell people to, don't know, try a bit more diet and exercise.
Exactly.
Think about how you live your life.
So that kind of got me really interested. So I went to talk to people at the labs, and I liked what they were trying to do. I liked the environment, and so I applied for a post they had coming up as head of their health effects team, and I was successful in getting that post. And I suddenly found myself catapulted from the world of academia, just a few hundred yards down the road, but into a very, very different world, the world of the regulator, but where the regulator needs to set aside resources and needs to invest in science to underpin everything they do. So let me give one simple example. We're talking about the inspectorate, and in a sense the influence they have in people in factories, but actually in order to take forward, if they have to, either what's called an enforcement activity where they're going to require people to change what you're doing, or go that further step into a prosecution which might end up in court, they need evidence. And in order to gather the right evidence, they need scientists and other people who are really experienced in what they do, who gather together that evidence which may need to be presented. Not all of it, however, is about prosecuting individuals. The vast majority of what HSC does is about education and guidance. And so where it's necessary to bring about improvements, it's how do we use that evidence to help people understand what are the right things they need to be doing to prevent these accidents, to prevent this illness.
And what kind of experiments would you be doing to gain knowledge about these, about the working world, about the kind of problems people might be coming up with their health?
Yeah, I'll give an example here outside the world of manufacturing, but one of the first things I did when I joined the laboratory, we had a problem not with respiratory disease but with dermatitis. It's quite common in most industries. This is a skin condition. It can both be caused by irritants, things that actually cause a breakdown in the barrier function of the skin, but it can also in some individuals be immunological. They develop a strong immune response, rather like asthma, and if they're exposed to particular types of chemicals, that immune response triggers something that looks very similar to irritant dermatitis. You get soreness in the skin, you get inflammation, you get itching, and eventually you get a breakup in the skin itself. And once that happens, you'll get a lot of bleeding and ulceration and damage. It's incredibly painful, you can imagine. It's difficult to sleep, it's difficult to do things. Believe it or not, there's a lot of dermatitis occurring in another industry apart from manufacturing, and that was in hairdressing. A lot of the young apprentices that joined, it was known that probably 50% of hairdressing apprentices never stayed in hairdressing after a year or two of working because they got dermatitis. Why did they get that? Well, we kind of understood why it was, because they spend a lot of time with their hands soaked in water and detergents, or they're using bleaching agents for the hair, or which are damaging to the skin. We knew why, and to a certain extent we knew mechanistically why. The question is, how could you actually stop this occurring? And when you start to work with a group of people like hairdressers, what's the best way to approach them? So this is where we divert away from my area of expertise to working with other colleagues, social scientists who I'd already talked to. And we said, what's the best way for us to work with hairdressers that they could actually participate and be involved in this research? Because if it's just us in the white coats telling them what to do, they'll say, sorry, I'm not listening. You don't know anything about what it's like to work. An example was one of the colleagues I had in the HSE laboratories, who was an inspector, felt convinced the answer to this was that they had to wear gloves all day. These disposable vinyl gloves. And if they wear that all day, they'll never have a problem.
Yeah, I saw some apprentices in my college they put gloves on,
Exactly.
latex gloves, and all day.
But if you wear those sort of gloves, they're occlusive gloves. They don't allow your skin to breathe. If you wear those all day, I can guarantee you within an hour, your hands will be feeling really uncomfortable. They'll be feeling hot and sweaty under the glove. And you can actually get irritant dermatitis if you do that for too many weeks.
It's not a solution.
So it's not a solution. So we started saying to our colleagues, what is the best way that we can work? So we actually ended up evolving an approach, working with the hairdressers, where we designed a study for hairdressers to look at when should they be really using gloves, because it was clearly gloves had a role to play. When was it best to use them? What were the best type of gloves to use? And how could they get involved in the research so that hairdressers themselves were doing some of the discovery of, oh yeah, we can, because up until that point they've been really objected to wearing gloves. To cut a long story short, when we involved them, we did a study with about 20 or 30 different hairdressing salons from the smallest to the biggest, and they got involved in doing that. And we published those results. They were part of, in a sense, the news. So it went out through what's called the Hair and Industry Body Industry Authority, which actually we'd also worked with. And they organised events where the hairdressers brought together and they heard about the results of the research. They also produced a little handbook for them, which we were involved with, which was designed with hairdressers' involvement. So it had very pretty pictures on the front. They won't have anything in their salons unless it looks right. That's an example of, in a sense, moving away from your area of comfort into an area where you need to work with other people to come up with solutions. As a consequence of that, throughout the whole of the North East Yorkshire, most of the hairdressers then were beginning to display and take pride in the fact they were part of this process of using the HABIA guidance in promoting awareness, even down to the colour of the gloves. They loved black gloves. They could have had blue ones, they could have had white ones, they were all available. But in the end, the right type of gloves they chose, this type of vinyl glove, they chose black because it looks more attractive when they're using them. And it started off a whole process where lots of businesses were really then trying to find out, we want to catch up with this, we want that to be part of our business.
Yeah. Whereas if you stomped in with your white coats on and said, you can't do this.
This is what you should be doing, you're doing it all wrong. So if you don't do it our way, we'll be in here and we'll take an enforcement action. So it's what HSE likes to do is really try and work to understand the problems. And you don't want to be going in enforcing, you don't want to be going in taking prosecution actions against people because they're very expensive. In this sense, they can be very negative approaches. Ideally, what you want to do is to work with people to understand what are practical solutions to those problems and then work out how you persuade the industry to do that. Sometimes it's easy to do that when you've got big companies who can afford to employ health and safety professionals. The challenge we all have to get to grips with is for a small business. They don't have the money to do that. The business owner is running around in circles all day trying to keep the business afloat. So one of the things that's interested me for a long time now is how can we work with small and medium-sized businesses to translate what we're doing into something that they can actually do themselves. The solution isn't always spend £100,000 on engineering solutions.
No. So what kind of experiments and what knowledge, I guess this huge amount of experience has led you down a path where not only can you advise on general working environments, but especially in manufacturing, there's a lot of cases where you're in quite a harsh environment. Yeah. And there's already a lot of legislation out there already to handle that and to try and protect people from that. But what, from your experience, do you find the biggest factors that affect people's health and safety in a machine shop?
Yes. Well, just to introduce that and explain how I came to that position when I got so involved in manufacturing. So I've been doing that work on dermatitis. At the first few years I was at the laboratories. Around 2005 we moved from Sheffield to a brand new purpose-built laboratory out where they also have a lot of the outdoor testing stations. There's a lot of work done on explosive devices, hydrogen gas storage, and the risk for explosion from storing things like hydrogen. And that had been going on from the very early days of HSE's laboratory out there, but they also had the laboratory based in Sheffield. And what they wanted to do was to amalgamate them on one site. So they built a huge purpose-built building. And for many of us, it then meant starting to commute through very beautiful countryside in the summer, but actually in wintertime, not so pleasant.
It's tough to get out to the Peak District.
Feet of snow and things like that, so that was a bit challenging. But it was a beautiful building, and that's where we moved in 2005. Around the time just before we were moving, we started to hear from clinical colleagues in Birmingham that there had been an outbreak of respiratory disease in a large engine manufacturing plant called Powertrain, which, as I say, manufactured engine parts. And we were all brought together in a very large meeting between several different government departments and some of the people from one of the hospitals in Birmingham and their respiratory specialists, to work out how we were going to investigate this outbreak of illness. There were hundreds of people working in the factory, and at our early stage it was quite clear. The early signs seemed to suggest that at least 100 people had conditions like asthma, and another thing which is a bit of a mouthful, it's called hypersensitivity pneumonitis. It's another immunological condition, so it's a little bit like asthma, but can develop to quite a chronic condition where people have real difficulty breathing and getting good oxygen transfer in their lungs. So it's quite debilitating as a condition. We're all more familiar with asthma and people having to use their nebulizers and so on to try and prevent the severity of their asthmatic attack. This is quite a difficult, long-term developing condition and so on. So that is a condition that was so rare that an occupational health specialist would be lucky if they saw 1 or 2 cases a year. In this one factory, in the initial diagnosis, there were 20 cases.
So something's gone quite wrong.
And there were nearly 70 or 80 cases of what seemed to be occupational asthma. This was one of the largest outbreaks that had occurred in the world that had been reported.
And what does it feel like? What's it like when you've got a case of this?
So, with asthma, particularly when that's often driven by things that are in the workplace, it can be both chemicals, but also can be proteinaceous materials. So bakers get asthma from working with flour and flour dust. We're all familiar there with the constriction of the airways, the breathing difficulties. It can come on very, very quickly. It can be very frightening. Again, it's affecting your ability to breathe properly. But we're all more familiar with the treatments that are available for asthma, and people who get that condition, get a diagnosis, then usually it will mean using a nebulizer. And the minute they feel attacks coming on, using that nebulizer appropriately.
And these were 20 cases of engineers with this case.
Oh, there were nearly 80 cases with occupational asthma. For allergic alveolitis, which is this hypersensitivity pneumonitis condition, it's very much more difficult because if you allow it to go on, there's very little more you can do with it. I mean, people start to have breathing difficulties. They'll have regular checkups with their doctors. They might need oxygen eventually, supplemented oxygen to help them breathe. You can
Forever, for the rest of your life?
Yes. I mean, some people, their life expectancy will be reduced by this condition simply because it's like a lot of other occupational lung diseases, this thing called fibrosing lung conditions where your lungs begin to get very gluey and they're not as elastic and it's difficult to get good oxygenation into them. You know, it affects your ability to exercise, to walk, you get breathless. This happens in welders as well. So these are they might take a long time, might take decades to develop these conditions, but for people who have had this sort of exposure in workplaces, they will find in their 50s they're struggling to stay in work. So they'll probably end up retiring early. Some people, even in their 30th or 40th decade, will basically have this problem.
And these are engineers working on machines, cutting components?
Yes, so it can be a variety of things that people are doing in machine workshops. The thing that we were most concerned of when the powertrain outbreak occurred is that a lot of this was occurring in machinists, people who are standing in front of machines, cutting metal parts and using lubricants. And it became clear fairly early on that this probably wasn't to do with the traditional neat oil lubricants that people have been using really for many decades before, but this was actually about people using water miscible lubricants. It started to get introduced in the 80s, these emulsion lubricants, which reduced the amount of mineral oil, say 95% water and other additives, many of the chemicals added into it, but obviously very efficient at both cooling and also at lubrication properties. And up to 10 years before the powertrain event occurred, other outbreaks had occurred in America and had been tied to the use of water miscible lubricants. And the reason is that these water miscible lubricants are often kept months or years, particularly where you have large central sump systems where you might have, in powertrain's case, 18,000 litres.
In a big tank, basically,
huge, massive
getting
tanks.
pumped to different machines.
Very expensive. Who wants to replace it? So it's just kept and kept and kept. The problem is, because it's water-based, you get microorganisms growing it, bacteria, yeast, fungi. You also get soluble metals eventually getting dissolved in it. With machining, you produce big metal waste particles that you can see with your eye, but you also produce at the nanoscale and the micron scale, very small particles that end up in the metalworking fluid. And of course, when you've got machines that are open and you're high-speed machining, you create mists and aerosols. You get volatile chemicals being released, called VOCs, but you also get droplets of metalworking fluid. And these droplets are so small that there's a lot, again, that you can't see that will travel into your airways. Many of them will deposit in your nose and your throat, but many are small enough. If you look at the average size distribution from high-speed machining, most of them are around 5 micron, and 5 microns is the perfect size to travel through your airways into your lungs.
And that's not what you want, basically.
And
when they get caught in the nose and throat,
it will as well.
That's okay, or
no, because in fact, when we went in and did the health investigation at the powertrain plant, and then subsequently many other plants were investigated, what you'll find is that the large majority of the machinists, particularly in wintertime when they close the doors, are actually complaining of sore throats, sore eyes, sometimes drippy noses.
Because their sinuses have got this stuff in it as well.
Yes, exactly. Now, they're symptoms. It's not necessarily a disease. They're just symptoms. And so the focus of HSE's investigations really became about, well, who's getting genuine disease like asthma and hypersensitivity pneumonitis? Because that's what they really want to prevent, people getting long-term disease. But as we've gone on to understand exposure in different circumstances to hazardous air particles, and I'm thinking now about all the work that's been done on traffic pollution, and traffic pollution we know also causes a lot of lung disease as well as cardiovascular disease.
Of course, we're inside the clean air zone as we speak, which is quite a recent thing.
Exactly. We understand those sort of things, and so we're taking actions to minimise people's exposure. There's not a lot really understood about that in manufacturing environments. And the focus naturally became about the metalworking fluid and about the machinists in front of their machines. And so a lot of the work that was then done was trying to measure how much are people getting exposed to, how much they breathe in. And to do that, you often end up putting sampling devices, little pumps, little sampling devices here, just under somebody's breathing zone. So you can determine, can we measure what's in the air in their breathing zone as a measure of what's actually they're taking in.
So you're trying to get an analogue of what they're exposed to and what's going to be going in their lungs.
Yeah, and we also did 10 years of research from about 2005 looking at how do the type of fluids become contaminated with microorganisms. There was suggestion that particular types of organism, there's a type of organism called a mycobacteria, which has been associated with hypersensitive pneumonitis when it occurs in pigeon fanciers. You've all heard of pigeon fanciers getting this lung disease.
I've never heard of that.
You've
but
not?
No,
yeah.
not.
And it's very similar. It's caused by mycobacteria. It's all the bird fecal material in the pigeon and all their feathers and all these sort of things that get into the pigeon houses. And of course the pigeon fancier spends a lot of time cleaning them out and breathing this substance in. And so eventually they develop this thing called hypersensitive pneumonitis. Farmers get it from mouldy hay. When they're harvesting, if the hay gets wet and they put it in the barn and then they're always going in to grab some, it's very dusty, they breathe in the moulds, that's known to cause hypersensitivity pneumonitis. So an obvious thing seemed to be that maybe moulds, fungi or certain types of bacteria in metalworking fluids are causing these conditions. So we did a lot of work on that. Frustratingly, nobody's ever yet come up with the real explanation of why people get these conditions.
So there were 20 cases in powertrain. And I guess, did you come to get to the bottom of why there were so many cases of this ridiculously rare disease?
Yes, I think the best consensus view was that at the time, industry was working to what we call these workplace exposure limits, the HSE sets. And there was a workplace exposure guidance value, which simply says it's good practice to bring it beneath this. It's not an enforceable exposure limit, just a guidance level. That guidance level for water-miscible metalworking fluids was set at about 1 milligram per metre cubed. And the occupational hygiene company that was working at the powertrain factory was monitoring the levels of exposure on a regular basis. And it was clear that people were getting exposed to about 0.7, 0.8 milligram, and some people above 1 milligram, but on average it was less than this 1 milligram guidance value.
So clearly that was not a good...
Which suggested exactly that it wasn't protective, it wasn't sufficient. And over the years what we've understood is really that it's probably a really complicated set of circumstances. It's to do with the contamination in the metalworking fluid. It's to do with microorganisms. It's to do with chemicals. It's probably in some individuals to do with the metals. It's a complex mixture and it's a complex environment. And so the best really understanding is at the moment that when people are exposed in these environments and they're breathing this mixture, some individuals are more predisposed to develop allergic responses. This happens amongst the general population. Not everybody gets asthma. Some people, for genetic reasons and familial genetic reasons, are much more likely, say, to develop asthma. Some people, because of certain history of illness, they might have had bad virus infections when they were very young, might be more predisposed to develop things like asthma later on. So environment, circumstance and genetics all combined together to make it more likely that some individuals in a particular environment will respond in a particular way. So coming back to our discussion about people just developing irritation symptoms in the upper airways, is that unimportant? Well, it's likely, and we know this from studies that have been done on things like traffic pollution, that many individuals who develop upper airway symptoms could be at an early stage, and if they carry on being exposed, could develop more serious respiratory. It's a bit of a continuum. Not everybody's going to develop the same response immediately. We're all different. And so some people actually have better defense systems in their body. And perhaps the worst they'll ever have is sore throats, irritation, coughing, but they never develop anything more serious. But you can imagine it, if in your working life, particularly say during the winter months, you go in and you're coughing your heart and lungs out all day long, it's not good for you.
No, absolutely. So was there
Not good for your quality of life.
after once these cases were discovered in Powertrain, what were the results? What was the conclusion? Was there an enforcement? Or was there a...
Yes,
what happened?
by that stage the factory had closed. In fact, they had moved all that equipment out to China.
Right, okay.
It had been sold on some Chinese companies. And so there was a very big investigation. It brought together a lot of experts, and HSE published their findings in some big reports. And that then began to make them think, we need to improve the amount of information that's available for people in workshops to work safely with metalworking fluids. And that really was the sort of seed of an idea to start working much more closely with the industry bodies making lubricants that were sold to these industry, as well as people in the manufacturing industry. And from about 2010 onwards, we'd already been working for several years with the UK Lubricant Association, because they manufacture the lubricants and they sell them. And they were also concerned that they should perhaps themselves be doing more to provide good practice advice to people using their lubricants. And so it took about 2 years finally to get all the right forces marshalled together. A plan was hatched that there would be a joint guidance document produced by the UKLA, but with input from HSE and other experts that were involved. And that really looked at it from the perspective of people in the machine workshops, particularly supervisors and managers. What do you really need to know and understand to prevent something like Powertrain? What is it about the way you look after these fluids? When do they really need to be thrown away? We can't carry on this process just saying, we've had them for donkey's years. Whenever we get bacteria growing, we just throw biocides in them to stop the bacteria growing.
So you throw some horrible biocidic chemical in that you're eventually going to be breathing in once it gets spun up and it's been through coolant.
That can't be a satisfactory approach. And in fact, in the worst performing factories, that's what you find that they're doing. Their solution is, if I got a problem, I'll stick biocide in it.
So you're making the coolant that people are getting coming into contact with every single day, you're making it more and more irritant, more toxic every time you add these chemicals.
I mean, a lot of the biocides will break down, so they're not there at the original concentration. But nevertheless, what you've said is exactly right. The longer you keep this fluid, the longer you ignore the need to look after its quality, the more you're building up this wonderful soup mixture of hazards. And
so you're then going to breathe in directly into your lungs.
The nature of the manufacturing environment is, if you're not machining at high speed, creating these aerosols, you often find other processes. And one of the things we did a lot of research on, people using compressed air lines. Why? Well, they have a good reason to use them, because components are often covered by fine metal particles or a film of metalworking fluid. What's the quickest and easiest way to remove that?
Blow it off with a compressed
air gun.
And what does that do? That will send aerosols around
what we showed with the research, it creates another fine aerosol. It creates very, very small droplets, most of them less than about 5 micron in size, many smaller.
So you might not be doing high-speed machining. If you're using an airline, that's the same effect.
And I think when we started the research, coming up to about 2010, visiting workshops, it's quite common to see a machinist, after they'd finished working on something, lifting it off the machine, looking at it in front of them and blasting it with the compressed air. So what we were able to do is show in our laboratories using a fluorescent dye in the metalworking fluid, and then basically we had a mannequin set up that was roboticized to follow a certain task of cleaning, so it could be done safely. We were able, with particular lighting techniques, to show this aerosol that was in the air. We were also able to show just how much people got on their bodies that they're unaware of. They're very small droplets, and on the faces, face covered in speckles, after just half an hour of using this. So clearly, if you spend 8 hours a day doing this, you're really getting covered. So that became also a way that we could communicate this risk to people. Here's something that actually you see is normally something you don't easily see.
Because it's invisible.
It's invisible.
Completely.
But now you can begin to see quite clearly, the implications of it.
On not only you, your skin, your clothes, but also on the inside of you as well. And
this comes back to how we use the science and the evidence to really often form communication. And so I think it was probably around 2014-15 when we worked with UKLA on this. We jointly attended a big MAC show at Birmingham, the NEC. And there we had a full-scale size of this mannequin with all the blue fluorescent dye showing up. And we just put that up because we also wanted to make people aware of the research and the findings. And it was the one time where the UKLA tend to have a fairly small stand there in previous years. And it's in the backwaters of the exhibition that you'd get a few people coming along every hour. But suddenly, lots of people started coming up, lots of apprentices seeing this and saying, what's this? What's this about? And we were able to explain it to them.
Yeah, because of that shock factor.
Just because they were able to see something that they'd not seen before. And they began to understand a process that they'd not been told to think about before.
Absolutely. Visualizing these invisible processes is kind of what a lot of companies are doing nowadays, and what we need to do to help machine shops understand what's going on under their roofs. And I guess that kind of leads us to one of the things you're doing now, amongst a lot of applications research, is you're working with a company to try and visualize this in a certain way.
Yeah. So again, I should explain where I am now. That in 2022, I got to 63 and finally decided, after being through COVID, that I was looking for a change, really, away from full-time working life. So I got to that stage. I'd been thinking about retiring for about a year or two. COVID came at the point that I originally intended to retire, but it was very difficult to walk away from that. A lot of governments, a lot of colleagues, a lot of government organisations were really having to work hard together to deal with a lot of issues that had come up through COVID, a lot of inquiries, and HSE had that. What were the risks in workplaces, particularly for people spreading COVID? And I'd worked a lot with the inspectorate for about a year and a half, as we all did, locked up in our lofts or our bedrooms, working remotely at home. And it was very tiring, it was very exhausting. So at the end of that period, I thought, I think it's time now that I moved on. But as I was thinking of moving on and talking to colleagues, including those that worked at the UKLA, they kindly said, well, we'd really quite like to keep on accessing your skills and your knowledge about all the research that we've done together, the guidance that has been developed for people in industry. So would you be willing to do that? And I didn't want to walk away from those relationships that I'd had. And so I said yes, agreed to work just a day a week for them. But as often happens, after the first 6 to 8 months of that, working on various projects, I began to meet other people who were also asking me, could I actually help out with them? Around 2019, though, I'd met Steve Thompson from a company called Fluid MS. And they had an interest, or he had an interest, in using low-cost sensors as a way to monitor emissions in machine workshops. I'd come to a similar conclusion around 2016, and we started research with some state-of-the-art sensors, which are much more expensive, going into machine workshops, trying to understand where the source of emissions. Is it all just about the machine and the machine door, which is largely where HSE's focus has been, or is it possible that we've got many other sources of emissions, material that you're breathing in? And actually we found that wherever we put these monitors, we could find sources of emissions at the back of machines, near compressed air stations, near compressors, and so on.
Yeah, because motors can emit carbon particles.
Electric motors and all these sort of things. So we began to think this is very similar in some ways to the issue we've got with roadside traffic pollution. You've got all these different vehicles passing. Some might be petrol, some might be diesel, buses and so on, all producing different mixtures. And then, of course, to add to that, you get other sources of pollution. If it's in an industrial setting, you've got industry pollution mixing to that. In the cities, you've got building pollution, all these sort of things going on. And so I'd met Steve about 2019, taken interest in what he was doing, because one of the problems I had is that although we had access to more state-of-the-art sensors, I thought to myself, well, small companies are never going to be able to afford to spend £5,000 on what's actually quite a highly technical piece of equipment that you need probably postgraduate experience to know how to use.
Absolutely no chance. Not in a 10-person machine shop.
How on earth are they going to use this? And I got intrigued by what was going on in pollution research in the United States, where the environmental agency there had also taken this very highbrow approach to we need state-of-the-art sensors to monitor pollution in big cities. But of course, in the late sort of 2019, 2020, with what's been happening with the climate change, we began to see obviously a lot of forest fires appearing. It's like 5 or 6 years. Concerns started, particularly big countries like America, about these forest fires. How do we know when these are occurring in these vast forests? How do we protect little communities? And what has been going on in America is a lot of individuals have been starting to buy these very low-cost sensors, costing less than $100, some of them just a few $100s, designed for people so they could measure pollution they're breathing in if they're riding into work. Along the road, and people started to get interested, different groups started to get together, work out how we could use these. And people have started to do this in a lot of the American communities living in the outback, in the forests. And the Environmental Protection Agency then began to realise that there might be something they needed to look at with these low-cost sensors, in that whilst they were low cost, they weren't really often reliable. What could they do to ensure that they could be used more reliably? But also because they were affordable, you could suddenly create very large networks of sensors. Lots of communities could have them at different outstations around where the houses, the centre of the village was or whatever. And in a sense, that's a problem very similar if you think about it in a manufacturing plant. We put a lot of effort when we're monitoring people's exposure to hazardous substances, and we talked about these workplace exposure limits, into appropriate measurement. What are they breathing in? So we have this way of measuring in their breathing zone. And this could apply to a range of different chemicals, or in case of asthma, to flour dust. And we sample it onto different types of filters or media that absorb chemicals. And it then goes off to an analytical labs, and they often do very expensive procedures. It often can take days to weeks to do the analysis. It's a very expensive, it's a very laborious process. It's necessary to find the evidence whether people have been exposed to those substances, but it's still expensive, it's still time consuming. And what happens in the meanwhile, if weeks later you find out someone who was exposed to a lot of hazardous substances, have they continued to be exposed to that hazardous substance until you've got the results to their company? And that's an issue of concern. It suggests that what we really need is a technology that duty holders can understand, that's affordable. Small businesses also can be involved in this, but it'll give them an much earlier trigger that something's going wrong. And that's where low-cost sensor technology can come in.
And it has a really, really wide application space when you're not trying to find that accurate value you can use for evidence for something, a legal procedure, for example, but something that can be used for general use every single day and get a feeling for what's happening in your machine shop.
Yeah, I think in a sense you've hit the nail on the head there. It's very important to distinguish between workplace exposure measurements, meeting these workplace exposure limits for those chemicals and hazards, particularly things like carcinogens.
Standard.
That needs to be done with a validated assay by the appropriate methodology that both HSE and industry agree with, and people need to carry on doing that because that's absolutely essential, because that's the evidence that HSE, if you've been doing your monitoring, have you been using this method? Where are your levels? That's absolutely essential. But there's a whole pile of other stuff that's going on, say, in machine workshop environments, where there could be emissions, where you're completely unaware of them. And you might legitimately doing your sampling to keep the records for HSE, because it is expensive, once a week. If you're a big company, if you're a smaller company, once every few months. And that's sufficient to say, well, we know where our average levels of exposure are. But if a lot of other things are going on that you don't know about, your process that you're using is not telling you anything about that.
Yeah, because the workshop's such a dynamic environment.
Exactly.
You could have a surface grinder running all day one day and then just being left off for another day.
Yeah. So when I retired, Steve approached me and said, I know you're interested in all this. Would you be interested in providing advice to the company? Because a lot of the discussions we're having people is about trying to understand risks from what they might be inhaling in their workshop. And again, we discussed this before. If it's more than just metalworking fluid, there's other sources of emissions. How do we explain to them what's now well understood from a point of view of public health, that when you stand by a motorway, you're breathing in a whole range of organic and inorganic pollutant particles? And there's big epidemiological studies that have been done on that really provide the evidence base that it really causes a lot of these long-term chronic illnesses. How do we get people in machine workshops to understand that? How do we provide the evidence to them? And how do we provide an affordable solution to them? So what Steve's company is trying to do is use low-cost sensor technology in machine workshops where people can monitor different processes and then look at what might be the solutions. And so what I've been really pleasantly surprised is, to me, it comes back to this thing about educating people. I've gone along with Steve, meeting a lot of his customers and finding out how they're using sensors. And what I'm finding is that people are a lot more engaged because suddenly they have control over this process. They're seeing live data, 24-hour data. There are often surprises they didn't expect. They've moved it near a machine and they thought there was no problems with that. And suddenly they found a very high level of emissions and they've gone to look. And it might be something like a leaking seal, which they had no idea about. And then they're doing something about that. So it seems to be a much more positive feedback loop. By having evidence they're seeing emerging on a daily basis, starting to ask sensible questions about what does this mean, and taking some actions about it, in a sense is having a much bigger improvement overall in air quality. And that's really quite a strong passion for myself. I think we do need, in manufacturing environments, people to understand how important this issue of air quality is. Metalworking fluid exposure is important, but it might only be one part of the total emissions in different machine workshops. Like many machine workshops have welding going on, and welding is really a critical exposure that needs to be controlled. HSE puts a lot of activity, a lot of inspection activity into making certain people are not, welding without wearing appropriate respiratory protective equipment and using proper exhaust ventilation to remove those fumes, because they're highly hazardous, the fine metal particles that you release with welding.
Yeah. And what have you seen when you've applied these low-cost sensors? Have you seen, I guess, the accuracy and the levels? You can't say, well, exactly you had this level, which means this, but in terms of general trends, what have you seen? Have you seen surprising results that actually might mean people might be working in what could be considered unhealthy environments right now?
And there's no doubt when you look into some environments, the average level of particles. So we don't have an equivalent any longer that HSC is supporting of an exposure limit or a guidance value for metalworking fluid, because they withdrew that after 2005 because it clearly hadn't protected people. And I think for good reason they've not put back in place one, because it's very difficult to identify what's a safe level of exposure. And so that's left a bit of a knowledge gap. So where else could we call on to our understanding of really what might be unhealthy air quality? The World Health Organization has set guidance values for these very small particles. One's called PM2.5, particulate matter 2.5, which are the 2.5 micron on average particles that go right into your lungs. And then they've got a PM10, particulate matter 10 micron particle, and they're for things that really end up in your upper airways and can cause problems. We've already talked about that. They've been standard guidance values that have driven a lot of the national public policies on where we need to reduce levels of emissions.
For example, the clean air zone here.
Exactly, the clean air zone. And they're now being monitored by state-of-the-art monitors all across the city here, by the sides of roads. And that's why we're spending all of this money. From an economic point of view, we're having to put a lot of money into this to try and drive down these levels of exposure. Because it's quite clear that whilst you might not everybody become acutely ill with levels above, say, 10 microgram or above 2.5 microgram, it might take months, it might take years. There are some individuals, as we now know, particularly the vulnerable, young children, or the elderly, who've got pre-existing lung conditions, where those 10, 15, 20 microgram amounts that they're being exposed to is sufficient to cause them in terms of a reaction of a provocation of their disease. For the rest of us, it might be decades. But it might mean in our 50s we're developing a declining lung function, much more quickly than we would have done if we'd been living in healthier air.
Absolutely. So in workshops, have you seen any environments that could be comparable to, like you say, we've got clean air issues in cities right now they're trying to fix. Have you seen comparable levels?
Yes, there are. I mean, if we look at it from the point of view of sensors, what the sensors are picking up, in many machine workshops, where they've got a high density of machines, they're cutting at high speed, they've got a mixture of older machines. Often you will see things like PM10 particulate levels, several hundred micrograms per cubic metre.
Yeah, which is way over.
Which is way over that guidance value of about 25 microgram that the WHO set. So it doesn't mean that people are immediately at risk to health, but what it does mean is people are working what is clearly what we define anywhere else now as poor air quality. What you'll also find, interestingly, when you use these sensor technologies, because the one that Steve has got can both detect these PM2 and PM10, PM2.5 and PM10 particles, it's also got a sensor that measures volatile organic compounds. And there's a thing called total VOCs, which is a measure of all the different types of small chemical compounds.
So there's a lot of different styles.
Exactly. So it's just a broad measure of the total VOCs.
And these are generally from organic matter
from solvents, from things like formaldehyde, toluene, xylene, all these sort of things that are volatile are released, particularly when you often heat or you've got a abrasion process going on.
And inside metalworking fluids, I guess you find volatile compounds when you've got bacteria? Or when there's been extreme
bacteria
heat?
metabolize, produce their own volatile, even things like hydrogen sulfide. And then there are natural, VOCs, part of the constituents in the metalworking fluid that are put in. So they can all contribute to some of the chemicals that you breathe in. The difference between particles and VOCs is that if VOCs pass into your airways and into your lungs, some of those will go straight across the blood lining, into the blood, and around your circulation, across the lung lining, I should have said. Particles will tend to stay on the surface in the lungs, but obviously if you're breathing too many, you can begin to overwhelm our ability to clear the lungs. And that's where often you start to get chronic inflammation and diseases occurring.
Yeah, so the load is really important as well, the level of the load that you're exposed to.
Consistency.
Wow.
So in answer to your question, there clearly is in lots of manufacturing environments poor air quality. But we're really just scratching the surface here, because what we need to do is find a way to encourage people to start using appropriate technology. Low-cost sense is one way. It's not the only way that we can obtain the right answers, but it's one way. And we have to be a bit careful because low-cost sensors, we've already said, are not necessarily entirely accurate. You need to think carefully about how you use the data. You don't over-interpret the data. Often if you're looking at real-time data, it looks very spiky and people can get worked up, all these little spikes, but if they're very transient, it may not be telling you anything significant. What we're tending to explain to people is look for the longer-term trends. What we're aiming for is if we know on average we're up here around a few hundred micrograms, what's that coming from? How do we reduce those emissions? Do we need more extraction? Local exhaust ventilation? Do we need to do something with the process that's generating those emissions so it doesn't generate as much? Could we change the metalworking fluid, because the metalworking fluid is the problem causing a lot of VOC emissions? What can we do at source to reduce those emissions and bring them down?
And also, could you stop using your air guns because those are atomizing liquids where they don't need to be?
You could at least demonstrate to somebody by using these sensors. When we place them around you, you can see the amount of particles you're generating. If you now do it under the enclosure of the machine, and we can actually measure outside, and you've got the extraction on, the levels will drop down, say, to 20 microgram, they're not 200 microgram.
And that's where you're talking about using a fan inside the machine, like a chip fan that you can put inside the tool holder spindle.
Well, that's one way that you can remove lubricant from a machine part before you've even opened the door. So that's a clever way of actually preventing you from needing to use compressed air. So much for cleaning components. There's a lot going on in the machine world that's improving the design of machines so that the components are all kept within the machine. After they're machined, you blow off that lubricant. Inside, it's all properly extracted. And so eventually then you've got a conveyor belt that brings out a clean component for you. But they're clearly state-of-the-art expensive machines.
And they someone who's got manual lathes and mills down the road.
They don't reflect what's going on in most machine workshops still.
Absolutely.
It could be 10, 20 years before we're there. So we've got to concentrate on how we help those small businesses that can't afford those machines. What are the other approaches that they can take? And so this measurement approach, what we're finding is that there's some workshops where they've spent a lot of money on local exhaust ventilation on their machines. And you can see that they've reduced these particulate levels from a few hundred micrograms down to something like 20 microgram. They've done an awful lot to improve air quality. But what they're finding then is they're still finding quite high levels of VOCs. And bizarrely, sometimes those VOC levels go up in the evening after the machining is finished. So that then started investigation. Why is this? Well, it turns out that some of this is because the actual through ventilation in this small workshop was switched off in the evening. So when you've got this volatile material being evaporated, nothing's carrying it away and diluting it. You've also got sometimes in these machine works a lot of warmth left in the building after they finish the machining, and you've got these large open sumps of metalworking fluid and volatilization taking place.
So like a coolant tank where you can literally look at the sump and you've got an open space right at the top. It's evaporating out of there into the atmosphere, and when you come in the morning, I assume it's hanging there waiting for you to breathe it in.
And that's the sort of problem. So when they moved the sensors around, what they found is it wasn't happening everywhere. It's probably because the sensors were originally placed near the machines and near the sumps. And then in the evening, while the particulate levels dropped after the machining finished, you suddenly got VOC emissions near the sensor. So developing a smart sensor network across machine shops, only probably those companies that can afford that to do that, they will begin to start learning an awful lot more about what's actually going on within their machine workshops. But smaller workshops that are using these sensors are still using them sensibly by saying, well, we'll stick it by one machine that we're concerned about, but then we'll move it on to somewhere else. It really is a sensible strategy to buy a small number of sensors, because then you could have one in an office environment. You can have one outside. In summer months, when people say open up the doors in the machine workshop, if you suddenly see at 8 o'clock when the machine workshop doors open up a big spike in emissions and there's not a lot of machines on, you need to start asking your questions. Is this because we're bringing outside traffic pollution in, if we're particularly by a busy road?
Absolutely.
And there's things like that you can start to answer and get an understanding of what's contributing and causing deterioration in air quality. But it's actually about directing you to where you can take sensible actions and measures.
Wow, comprehensive, if I do say so, Gareth. That was fantastic. So we've talked about a huge amount of your background. We moved on to HSE, and also a huge amount about what goes on inside machine shops, especially the air quality inside machine shops. And I think you gave some pretty good advice people could use, hopefully today, to try and improve the quality of the environment in which they work, in machine shops and factories. So yeah, this has been the Data Driven Manufacturing podcast, talking about everything inside a machine shop that is actually really important, but you cannot simply see. You need to use sensors, you need to use some kind of, need to use data gathering and try and visualize what's happening in the machine shop. And you can do that with all the low-cost sensors that Gareth's been talking about, with a company called Fluid MS. That's run by a man called Steve Thompson. We know him quite well, and also you advise them as well. So thank you so much for your time today, Gareth. I think that's it.
Thank you for inviting me.